We're back in the TMC Net newsroom, and we're here talking about 4G WE, and we're talking about some of my favorite things to talk about, testing issues, with my pal Carmine Caferra, Berkeley Veritronics. He is Eastern Eastern Regional Sales Manager. He's been a friend of mine talking about this industry with me for quite some time. And what have we got with us this time? This looks like a yellow fin, or
it is a yellow jacket.
Jacket.
This is our tablet version. This is our flagship Wi-Fi testing device, and we brought it here to the IT Expo show at the 4GWE Pavilion to show off the wares and how people can test, optimize, and also you do indoor and outdoor site surveys.
So speaking of which, we're indoors, and I'm sure we've got at least 5 or 6 Wi-Fi.
We've got plenty more than that. This is a hostile environment for anyone trying to get Wi-Fi packets thrown around.
So what are the features? What can I do to try to figure out how to save myself here?
Well, the primary features of the device are the ability to scan for any selected channels, whether it's 2.4 or 5 gigahertz. Once those are scanned and captured, you can drill down and basically take measurements after selecting the particular access points. The instrument's capable of doing radio frequency multipath analysis, where we can process the information in the time domain, take a look at the main path and reflected paths. We can display the information of that also in a delay spread screen. We can also use the instrument to do antenna alignments, where you're trying to do point-to-point or point-to-multi-point access point.
In N, we're beam-forming, so in theory we've got solutions here to help us do the beam-forming stuff.
Well, it'll check on directional antennas.
Right.
You know, especially for point-to-point and point-to-multi-point links. Right. It'll do traffic analysis on the packets for that particular access point and bin those accordingly. There's a signal strength over time screen, which is very useful, especially with this direction finding antenna that I've got attached up to here. The use of this screen will actually take you to the physical location of the access point. In some cases they're trying to look for rogue access points. In some cases you're trying to find radio frequency interference. Additional screens available, security overlay that's on the access point, and as in prior IT shows to this show, we were also talking to the industry about our ability to read the 802.11n capabilities that have been programmed into an N-capable access point. Right, so there's 2 screens for that on here, which will verify that the access point's been set up properly, code channels have been located properly, and you can squeeze out the above 100 megabit per second throughputs that are available on an 802.11n.
Now the interesting thing is we just had a session inside the show about 5 gigahertz and basically how that's going to really be a wonderful place for Wi-Fi to flourish, and you're nice and rugged, built for the outside, and it might be that we see the hotspot world kind of explode in the near future.
Well, we're hoping so. As a matter of fact, you mentioned the 5 gigahertz. That is an excellent ground for moving 802.11n capability, because the channels pair up better. Each channel at 5 gigahertz is independent of the next. There's no channel overlap. Same stuff that you find down at 2.4 gigahertz is not as friendly.
Right.
There's 5 megahertz channel overlap there. But the channels pair up very nicely at 5 gigahertz, and so you can have that confirmed with the instrument. And then ultimately there's a radio frequency spectrum analyzer built into this to deal with interferences. It's all laboratory grade and calibrated. Supported also with mapping software for indoor and outdoor situations, where if you're outdoors using GPS with a vehicle, or you're indoors using a PDF type of a file for the floor plan, and then you overlay that with the data points.
So now, a lot of the companies here are call center types. Now let's make the giant assumption that if you're big enough for a call center, you probably have a campus environment, and if you've got a campus environment, you're probably a good solution for people to try to figure out how to make it so that in building and outside the building, exterior, you've got full coverage, right?
It'd be an excellent application for a VoIP type of a setting, where they have to verify coverage overlays both indoors and out for that area. Depending on the size of the area, this study can be broken up into segments that are easier to deal with instead of one big dimension drawing. The instrument does have the capability to support that as well.
Cool, cool. So now, we brought up the yellow jacket, but that's not your only device in this world.
You're right.
Testing. So what else do
There's something else yellow over at the Berkeley booth, and it's the yellow fin.
Right.
That's for WiMAX. We have two modules, one that handles 802.16e, too many 802.11s here, and one for 802.16d, the fixed WiMAX. Unfortunately, there is no WiMAX carrier in the exhibit hall right now, so I have that instrument just doing spectrum analysis to show it off, but I've got you know, some documentation and things like that, specification sheets.
Well, if you were over by me, we do have WiMAX coming to us. So
okay.
So we should have brought you in to test just by us local.
That would
have next time.
That would have been cool. Well, let's make that a date.
Okay, great. Carmine, thank you very much. If people want to reach out to you, how do they get to the website?
Well, it's www.bvsystems.com. Our central phone number is 732-548-3737. I'd be happy to speak with them.
Geez, they're nearby. Great. Thanks a lot, Carmine.
All right. Bye-bye.